Sounds like we've kind of come to a synopsis of what we're talking about here. Still crunching away. So you've got this lottery game. Sounds like Keno, kind of is Keno-ish. And let me read real quick here. 80 numbers, draws 20, and you match either two, 3, or 4 of them. If you match one or none, you don't win anything. So that they have the odds adjusted so that, well, what's going to happen? In number 8, what was the expectation of the game? Negative 41 cents. So it's just like Chuck-a-Luck. Basically, instead of walking up there and paying $1, just walk up and give them 41 cents and say, I'm not even going to get a ticket, I'm just going to leave now. Because that's essentially what's happening. Over time, you're going to lose 41 cents per ticket. That's essentially what's going on, right? That's essentially what's going on. Okay, and that's the way all lottery games work. Until they goof, which is what happened back in 90, whatever it was, 96, 97 when this happened. So what they decided to do to spur interest was they said, okay, we're going to double all the payouts on this game. Double all the payouts. So in other words, where you used to win $55, was that what it was? Yeah, 50. Well, you cleared 54. Right. They would give you 55. They're now going to give you 110, which is the double of that. Yeah. So it means you clear 109, which is up, and we're on number 9 here, 109. Instead of clearing 4, you're now going to clear 9, because instead of paying you 5, they're going to pay you 10, and so forth and so on. But notice, you match one or no numbers, it's still a negative $1. Still a negative $1. Now, what I want, right? Now, Haley said something cool over here. She said, wait, the probabilities haven't changed at all. Awesome observation. The probabilities haven't changed at all because the numbers are still randomly coming out like die rolls. Dice are getting rolled, numbers are popping up. That's not going to change. You're still losing. How often? How often do you lose at this game? Look at the probabilities. You lose 74% of the time, which means you lose 3 out of every 4 games you play. And you're still losing that $1 all the time. You're still losing that $1 all the time of those 74% of the times. But here's the difference. Now the payoffs have gotten so large for these somewhat rare events. I mean, you're only hitting to match all 4 numbers 3 in 1,000 times. But when that happens, you get so much more money now that what happened to your average winnings at number 10? Now you walk up there and you say, Mr. Cashier, here's my $1 I was going to give you to play this game. But better yet, I got a better idea. Put the $1 away, put your hand out, and demand your 19 cents. And when he asks you why, you could say, on average, I'm going to win 19 cents per game. So why don't we all just cut to the chase, save us all some resources and time, and you hand me 19 cents. To which, of course, he retorts, because he took Math 243 last term. He retorts what? What does he retort? What does he say? Get the hell out of my store. Hey, you, security. No, he retorts that that's an average. You still have to play the game to see the average kick in. And that's exactly what these kids did. These kids played thousands of games. Now, Jen brought up a very, very good question. And that question was?
Oh, that you have to have a lot of money.
Right. These are college students. Chances are they don't have inordinate amounts of sums of money laying around. And they ended up playing how many games? 1,500 tickets times 4 days. So 6,000 tickets. Each of the tickets had 20 games on it. At some point, they had to start with money. So what I'm guessing is they were able to find some of their stat professors to loan them some money. Not that I have any either. But these guys, I'm assuming they were at a university. They get paid a little bit more, a little better at universities. Front us some money. All they have to do is explain there's a 20% return on your investment. That's ludicrous. That's like illegal. Look at checking accounts and banking accounts. Savings accounts right now are like 0.5%. 20% return, 19% return? Ludicrous. Ludicrous. Does not exist except when New York State screws up. See the amount of money these guys cleared? For 4 days of work? Not bad. Not bad.
It's weird though too because when they raised the bar or doubled it,
yes,
whatever, you can't break even. You either lose or you gain.
Right. So somewhere in there you could. I love this, Haley. I love this. What Haley just asked about is we went from losing money on average to gaining money on average. At some point, you have to break even. There's a payout that makes it break even. And I'm going to have you guys analyze it, your homework for next time. On Chuck-a-Luck. I'm going to have you futz with this amount right here. I'm going to have you futz with this amount right here to figure out where that break-even point is. Because that's the point that casinos want to know about. Because that's the point beyond which they can't go. Because they're going to start losing money. So let's say the break-even point is $100. If we pay you $100 in Chuck-a-Luck for when you hit all 3 5s, that's when the average is 0, which means you don't lose money and we don't gain money. That means they keep it below $100, which makes sure that you're losing money. Maybe not as much as when it's a 10,
Right.
but you're still losing money on average, and it's all about being on average.
And actually, they also watch the tables.
Yes.
The table which begins to win.
Oh, for sure. But they're looking for inconsistencies outside of probability. Like, what I'm making the assumption in all these arguments is these are staying consistent. If you start cheating the system, you're making these go down and these go up. That's why when David mentioned he sticks to blackjack, I don't analyze blackjack in this class because blackjack has a skill component. Poker has a skill component. You have to know when to draw. Was it Kenny Rogers? Gotta know when to fold 'em, whatever the hell that song is, like the old country tune. It's a beautiful song. I'm doing it horrible injustice up here. But that's the idea. There's a skill component to those games. Whereas this is just dice falling and numbers coming out of a computer screen. Yeah? Good. Very good questions. Very good comments. Very good connections today, my friends. We'll see you again on Monday. Please bring questions on probability distributions.
Make sure you put your name on that.
And make sure you put your name on it. And turn it in if you want to count it as a quiz, although I think we all should, because we all know the answers now, which is even better.
So I can.
And we'll shut the camera down, because the camera doesn't need to hear me sing Kenny Rogers.